Alright, let's get started with 5.3, translating parabolas. So, in this section we're going to learn how to use the vertex form of a quadratic function. And so that's our only vocab for this section, the phrase vertex form of a quadratic function. Alright, a couple skills checks, couple skills we'll need, and so let's check them first. Identify the parent function and then graph it by translating. So on number 1, our parent function is y equals negative x, which looks like this, straight down. And then we need to translate it, so if we remember, this plus 2 means we're going to go up 2. So from our original equation, we'll go up 2, 1, 2, and then have the exact same line, just shifted up by 2. Alright, so you try 2 and 3. I'll do number 4 here to give you a push on the next section. Write an equation for each translation. So we started with y equals 2x, and we're going to translate this down by 2. So that's going to be y equals 2x, and then down by 2 means a minus 2 on the end. So that would be 2x translated down to 2x minus 2. Try number 5. When you're ready to go, move on, and we'll get started with this section. Alright, let's talk about the vertex form of a parabola. So in chapter 2, we started with straight lines and we moved them around, and we also had absolute values and we moved those around. Alright, we're going to use the same type of skills to start with parabolas and move them around. So we're going to start with just a basic parabola of y equals something x squared, ax squared. And then we're going to be able to move it about using 3 different constants, a, h, and k. Alright, so in this, h, since it's with the x, is going to be a horizontal translation. Alright, so whatever this number is. But remember, the formula is x minus, so it's the opposite. If it's x minus 3, we're going to go right 3. If it was x plus 3, we would go left 3. Right? And that's because if we made this 0, to get h on the other side, we would have to change the sign. Right? If it was minus 3, to get x equal to it, we'd have to move it over, and it would become a plus 3. To figure out the y shift, y equals k, so that one we can just look at. Don't have to change the sign for k. K is going to be shifting up and down, right? All right, and then remember, if a is positive, we're opening up, and if a is negative, we're opening down. So let's use the vertex form and graph this parabola. There's a note in your textbook that says a function of vertex form is easy to graph, so we like it when it's in this form, and you'll see why here. So we've got our coordinate plane. We're going to go to 2, 3, 2 for our x, 3 for our y, and that's going to be our vertex. All right, so that's why they're saying this is fairly easy, because we know what our vertex is. All right, so then the next step is we need one more point. I'll just put this in here so I don't forget it. 2, 3 is the vertex. We need one more point, and the easiest point to use is plugging in 0 for x. Right? So I'm going to take our equation, negative 1/2. Instead of x, 0 minus 2 squared plus 3, and let's see what we get. Oops, don't need a parentheses. Let me fix that. Let's see. So it's negative 1/2. Negative 2 squared is 4 plus 3. Negative half of 4 is negative 2 plus 3. And negative 2 plus 3 is 1. So if we plug in 0 for x, we get 1 for y. And since we know about our axis of symmetry, right, this is the axis of symmetry, we must have a symmetric point. Since we went 2 to the left of the axis of symmetry, we must go 2 to the right and have our third point. And from there, we've got ourselves a nice parabola. This is opening down. Does that check out? Yes, it does, because we have a negative there for our a. All right, so that's how we would graph a parabola in vertex form. So, your turn. See if you can do it for that one there, and then answer the question for B. All right, so now we're going to go backwards. They give us the equation. Our job is to come up with the parabola. So, we know the equation in vertex form is y equals a, x minus h squared plus k. vertex form. So since we know the vertex, we know h and we know k. At the vertex, right here, the x value is 3, so we've got x minus 3. And the k value is 4 plus 4. We just don't know what a is. Right? We know it's going to be negative because it opens down, but we don't know exactly what it is. But thankfully we have one more point. And so we can plug this in for our x and our y values. Our x is going to be 5. Our y is going to be negative 4. So from there, let's figure out what a is. Negative 4 equals 5 minus 3 is 2. 2 squared is 4. How do we get rid of 4? Let's minus the 4 and get negative 8, not 0. Careful there. So a is negative 2. And that makes sense because this parabola is opening down. So negative 2 is a. Let's rewrite it for our final equation. Y equals negative 2. X minus 3 squared plus 4 would be our final equation. Remember that we want to leave y and x as variables in our final equation. All right, your turn. See if you can do the same thing for understanding check number 2. All right, so now we got this word problem here. The photo shows the Verrazano Narrows Bridge in New York. It's the longest span of a suspension bridge in the U.S. And so the suspension of the cables, okay, simulates a parabola. And so we're going to model that parabola with this equation here. And this should look pretty familiar because it's in vertex form. Here's your a, x minus h, plus, oh, we're missing k. What would k be? If you said 0, nice job, plus 0. You could write a 0 on the end there, right? So plus 0 for k. So let's see if we can come up with an equation and then answer these questions. How far apart are the towers? Oops. I want to cross it out, just trying to underline that. And how high are they? So let's start with a quick little sketch of our graph here. It's going to look like this. And how do I know that? Because I know that the vertex is at 2130, comma 0, right? 2130, comma 0. And so the suspension bridge is going to look like that. So first things first, if these were the towers, how far apart are they? Well, since this is symmetric, halfway gets us 2130. The other half must also be 2130. So how far apart are these towers? 4260. Just add those up. They're 4260 apart. And how tall are they? Well, let's figure out the y value if x is 0, right? Because right here on the y-axis, x is 0. So let's plug that in. Y equals 0.0001432. 0 minus 2130 squared, okay, plus 0. Don't expect you to be able to do that in your head. Let's go grab a calculator. So we've got 0.0001432, and then we have negative 2130, and that's being squared. Hit enter, and 649.68. That's going to be the height of those suspension bridges, towers. The height of the towers for the suspension bridge. So your job for understanding check 3 is suppose the towers were 4,000 feet apart and 600 feet high. So they're giving you the information in the graph. Your job is to come up with the equation. So similar to what we did in understanding check 2. Give that a shot. All right, lastly, let's convert to vertex form. So they're going to give us this, and this is called standard form. Remember where this is ax squared bx plus c. Let me write that underneath there. Standard form is y equals ax squared plus bx plus c. We want to convert this into our vertex form. Y equals a x minus h squared plus k. So let's go ahead and see if we can do that. All right, so we want to figure out where our vertex is. Thankfully, we have a formula for our vertex. Remember that the vertex is x equals negative b over 2a. If if we remember that one. So let's plug this in. We've got negative 10 over 2 times 2. So that's negative 10 over 4, which is negative 2.5. All right, so we've got h now is negative 2.5. So we're going to have to change this to a plus 2.5 because it's minus a negative. Okay? And now let's think about the k on this one. Okay? The k at the vertex form, if we go from the standard form, do you remember what the that's going to be? And if you said C, you're correct. So this should be 7. Okay. Oh, hold on one second. All right, I apologize with that. I got greedy. It's not 7. It's only 7 if we don't have a B. That was going too fast. From 5-1, there was a point where if you don't have a B, if B is 0, then the vertex's y value is C. But we do have a B here, so we have to plug this back in to figure out the K. So let's do that in our original. Y equals 2. We've got our x, negative 2.5 squared, plus 10 times our x, plus 7. All right, let's go ahead and clean this up. Negative 2.5 squared. We can use our calculator here. Negative 6.25, and that was times a 2. And then plus 10 times negative 2.5. And then plus 7. And we've got negative 30.5. Okay, I pause that for a second because that doesn't sound right, and I did make a mistake. Did anybody catch it? When I squared this, I forgot to put the negative in parentheses. I can't go back and look at it again, but that should be a positive 6.25. So this should be a positive 12.5. 12.5 plus, let's start from here again, 10, negative 2.5. So negative 12.5, and then let's add that 7 on the end. Negative 5.5. That looks right there. So just be careful on those calculators. Don't make the mistake that I did right here. Negative 2.5. Make sure you're in parentheses and square it. I did not do that, and I would have gotten the wrong answer if I didn't catch it there. So negative 5.5 is our y value. So that's our k value, the y value of the vertex, right? So we can plug in minus 5.5 right here. And all we're left to do is plug in an A, and thankfully we already know what A is. A comes from the standard form. It's the same A. So we can put a 2 right in there, and we've got it. So the key thing on this to go from standard to vertex is remembering that the x of our vertex, not just any x, but the x of the vertex, is negative b over 2a, and the y of the vertex is plug it back in. And those letters are going to be your H and your K. All right, so those are the steps. Your job is to take this equation and turn it into vertex form. Good luck. If you have questions, we'll go over it in class.